Hey guys, Mr. Milton here. Today we're going to talk about factoring trinomials when a is not 1. Okay? Factoring trinomials when a is not 1 becomes a little bit more difficult, as some of you guys might have discovered. When a is 1, it's kind of easy to find those values and kind of unnecessary to use the box. If you haven't found that shortcut, ask me about it later. Okay? Um, but today we're going to factor when a is not 1. My biggest tip for you is to always check for GCF before you start factoring. Okay, if you try to use this X box method, when there's a GCF still there, you will get an answer that's slightly off. Okay, so let's look at our we have a few examples to look at. Let's look at our first one. We have 6n squared plus 23n plus 7. Okay. Now, you might have seen that say use the X box method. Use the X box method. Okay, now the X box method helps us out because when a is not 1, before we were saying to find two numbers that multiply to give you C. Okay, in this case it's 7, and two numbers that add to give you B. Well, what's going to happen now, and I'll say I lied to you guys last time. I said two numbers that multiply to give you C, but it's actually two numbers that multiply to give you A times C. And I could just say C last time because A was always 1, so it didn't matter. Okay, but for this, when A is not 1, we're trying to find two numbers that multiply to give us A times C. In this case, that's 42. And two numbers that add to give us B. It's 23. Okay. Like I said before, if you have trouble or difficulty finding those numbers out, you can always do the T-chart and find out 142, 221, 314. I think that's right. There's more of them. But I see that 2 times 21 gives me 42. 2 plus 21 gives me 23. So those are my values. I use the Xbox method though because I don't want to put this number 42 in my box. Okay, I need to see it. I need to be able to find numbers that reach to multiply 42 and add to give me B, but I don't want 42 in my box. So I'm doing this outside of the box. And then inside the box, the things stay the same. My first term goes into the first box, 6n squared. My last term goes into the last box, 7. And then these two terms I just came up with, right, I will split up between those two boxes like we did before. Okay. And now going through each row and each column, I'll find out the GCF. So going through this row, my GCF is 2n. Going through this row, my GCF is 7. Through this row, my GCF is 1. Okay. And through this row, my GCF is 3n. And so, all my signs are right. Okay, they're all positive. That makes it easier. So I have 2n plus 7 times 3n plus 1. And those are my two factors. Okay, so just a slight change using B, the same. That stays the same. But now we have to really worry about A. We're using A times C, which is 42 in this case, outside the box. Still using our first term in our first box, our last term in our last box. Okay. Okay. If you discovered the shortcut last time, notice that it does not work. 21 and 2 are not inside of our factors. Alright, let's try it again with this next problem. If you feel like you got it, you got them down, you can write them down and check my answers. But if not, follow along with me. Okay. So here I need to find two numbers that add to give me negative 20, add to give me negative 26 and multiply to give me negative 56. Okay. I'm going to make my little table here until I run into the numbers. 56. Okay, this side is negative, so one's going to be negative and one's going to be positive. the sign is negative, so my bigger number is going to be negative. So I've got 1 and negative 56. I've got 2 and negative 28, and that works. Okay. So 2, negative 28. Those are my values. First term, first box. Last term, last box. These two terms, 2x, negative 28x here. Alright, going through, finding my GCF. That's 7x here. That's 2 here. That's negative 4. Negative 4. And that's x. Alright, and so those should be my two factors. I'll go check, make sure that everything comes out. Negative, negative, positive, positive. Okay, that looks good. I have 7x plus 2 times x minus 4. Highlight those answers for you. Okay. Alright, in our last problem, we got 20x squared plus 80x plus 35. And I'm looking at this problem right now, and I see that there's a number that goes into all these values. Okay, there's a GCF, and we need to make sure that we take the GCF out before we continue on and do the Xbox method. So I'm going to factor out a 5 because I see that that's in all the numbers. So 5 factoring out, I'm left with 4x squared plus, what is that, 16? 16x plus 7. There we go. Alright, now I'm going to look at 4 and 16. Okay, they have 4, but 7 doesn't. 7 doesn't have x. Okay, so I factored out my GCF. I'm going to make sure that I remember that in my final answer. I'm going to use this to factor my trinomial. Okay, so I'm looking for two numbers that add to give me 16 and multiply to give me 28. 4 times 7. Okay, thinking of the numbers. They're all positive, so don't have to worry about that. 128, 214. Oh, there we go. 2 and 14. Okay. So, first term in first box. So looking here, 4x squared. Last term in last box, that's 7. Splitting those two between here, 2x, 14x, and taking out the GCF. My GCF here is 2x. My GCF here is 1. My GCF here is 7. My GCF here is 2x. Okay, all positive, so it should work out. Okay, good. And now I'm writing my final answer. I have that 5 that I factored out earlier. And then I have 2x plus 7 and 2x plus 1. Alright. And that is my final answer. So that's how you use the Xbox method to factor trinomials when A is not 1. Okay? Remember, check for the GCF before you go. Okay? And then everything else in the box method stays the same. Okay? So hopefully you weren't over dependent on that shortcut before if you discovered it, because you will need to use this box method in order to solve these problems. Okay? Factoring by grouping also works the same way. So if you liked factoring by grouping last time, remember it's the same thing. Don't use the box. 7x squared plus 2x minus 28x minus 8 and do the groups. Box method is essentially just grouping in a different package. Okay, we'll practice more on this, but if you get this down, then you're going to be pretty good with this chapter. All right, see ya.